Hey guys, today I'm going to go over 3, 4, day 2 zeros of a polynomial with you. I'd like you to first take a second to work through this teamwork together. Now, if you look at the problem, use the graph of f of x and your knowledge about zeros to determine the equation. I can find on my graph that I have a 0 here, here, and here. That means my zeros are -1, 0, and +2. To create an equation, I can put it in intercept form. So I know that I'm going to have some a value. I'll have to make sure that it's 1 or if it's something different. If I have 0 as a 0, that means that I had to have a single x in here. If I have x minus 1, that means it had to be x plus 1 as a factor. And if I have +2, that means x minus 2 as a factor. So now what I can do is I can choose any point on my graph, any nice point, this one I could use. So the point I'm going to use is going to be 1, 1, 2, 3, -4. So 1, -4, and I'm going to plug that in for my x and my y value. So when I plug that in, I have 4 equals, leave the a because that's what I'm solving for, times 1, times 1 plus 1, and times 1 minus 2. So that's going to give me 4 equals a times, this gives me 2. 1 minus 2 gives me -1. So -1 times 2 times 1 is going to give me -2. So if I solve for a, I divide by -2. So a is -2. So my final equation is -2. Oops, let me erase that. In place of my a, I have x, x plus 1, and x minus 2. There is my final equation. It doesn't specify that I have to be in standard form, so I can keep it in intercept form. However, if I wanted to, all I would need to do is just multiply these binomials and then distribute in that -2x to be able to get a standard form equation. Okay, last thing we're going to talk about today is multiplicity. I know we kind of talked about yesterday a little bit, but I just wanted to address it a little bit more. So what I'm going to do is I'm just going to draw one graph and show you what that's going to look like. Okay, so I'm going to go ahead and put a graph here, and I'm going to sketch a picture for us. So I'm going to say we've got a 0 here, and we've got a 0 here. Let's say that this is an odd degree function that is positive, so I'm going to go like this, and I'm going to pass right through. So why did I do this? Whenever you see your graph looking like this, like it is hitting a 0 and turning right around, this is what we call a bounce. It's what we talked about yesterday. And this is when you have an even multiplicity. Okay, so that means if I had, like, for example, x plus 4 squared times x plus 3, my zeros would be x equals -4 and x equals -3. And -4 would be an even multiplicity, because there's 2 of them, right? Because if I have x plus 4 squared, technically I'm getting 2 of these for my 0, so therefore that's an even multiplicity. So this is actually going to bounce right here on this graph. If I look at the other side, you'll see that this one crosses through. This is what we have as an odd multiplicity. So whenever you have an odd multiplicity, so for example, if you had like x plus 5 cubed times x minus 2, my zeros are going to be x equals -5 and x equals +2, but there's going to be 3 of these. If there's 3 of those, that means that there is an odd multiplicity, right? So on a graph, I know this is not the correct location. However, I should have put, let me go ahead and make that change so it makes a little more sense for you. If I had x minus 5 cubed, that would give me a +5. So therefore, it would actually cross through the graph. Okay, so passes through the x-axis. When you have that odd multiplicity, it's not bouncing off because it's not just hitting it once and then turning for twice. It's actually going to cross through. If you think like odd degrees, they cross through. So if you ever get an odd number of zeros, so the same zero, you know that when you're sketching the graph, it's actually just going to cross through. Okay, so good job today. You guys will get a worksheet that you can work on, and then when I'm back on Monday, we will go over any questions you might have, and I hope you have a great weekend.